Whenever people think about the dangers of the ocean, the most likely image to first appear in their heads would be that of the shark. Many horror movies based around the ocean feature this animal as the focus of the story, and around the world people know to be extremely wary around sharks and their hunting grounds. But what makes this creature a muse for so many, arguably good, films, and why are people so scared of them? Is it the fact that after millions of years the shark seems to have not evolved at all? Welcome to Evolutionary Perfection, and today we'll be looking at why the shark is the perfect predator. Excluding the whale shark, megamouth shark and the basking shark, all sharks have teeth embedded into their gums, unlike mammals whose teeth are connected to their jaw through the gums. This means that the shark can replace these teeth about once every 9 days. The shark makes this possible by growing teeth in advance behind the jaw, and over a lifespan they slowly move forward, replacing damaged or missing ones. On average, the shark loses about 30,000 teeth in its lifetime, which attracts collectors from around the globe, and is preferable from reaching into one's mouth and taking it by force. Shark teeth can come in various shapes. For example, the teeth of the dogfish and nurse shark are flat and dense, well adapted to feed on mollusks and crustaceans found on the ocean floor. The blue and bull shark possess sharp, needle-like teeth adapted for catching and holding slippery and small prey, such as stingrays, flounders, and, in the bull shark's case, even other sharks. The likely image of shark teeth that come into people's minds would be pointed lower teeth and sharp triangular upper teeth belonging to the large predatory sharks such as the infamous great white and tiger shark. These teeth are ideal for preying on seals, dolphins, other sharks, and occasionally small whales. The pointed bottom teeth help grip the flesh, and the triangular serrated teeth help it cut into smaller pieces which are easy to swallow. The filter feeders also have teeth, but they have been reduced to the point where they're non-functional and never used in any circumstance. Shark skin is skin like no other marine animals. The contrast in its slippery appearance and rough texture is due to small structures called dermal denticles, which resemble small teeth. Actually being platonic scales, these structures contain enamel, which adds strength and protection from injury from the shark. Because these scales point towards the tail of the shark, it creates a sandpaper effect of making it rough if you feel it from the tail to the head, but smooth from head to tail. This could also be a minor form of defense from flankers, as it would be likely for softer skinned animals to be badly damaged if they brushed against it from behind. These scales are also well adapted for helping the shark to be free from turbulence in the water, along with being more streamlined than its body shape provides. The scales direct water through the grooves and decreasing the friction of water on the shark, meaning less effort has to be put in to maintain its speed. To maximise this effect, they are arranged in a mosaic pattern, forming a helix around its body. Because sharks have cartilage instead of bones, these scales are directly connected to muscles associated with swimming, allowing the sharks to save energy and to swim faster for extended periods of time. Whilst on the topic of skin, let's talk about the camouflage of sharks. In open water there is nowhere to hide, which can be problematic for both prey and predator alike. Because of this disadvantage to the predators, sharks evolve different forms of camouflage to assist them in the hunt. Open water sharks such as the great white and the blue shark use counter shading to help them stay hidden from prey until they get close enough for the kill. Counter shading works by their lower bodies being coloured light grey or white, which blends them in with the light of the sun and the surface of the water, camouflaging itself from fish that live below near the ocean floor. Its upper half is coloured dark grey or blue, so fish above cannot tell the difference between the shark and the deep blue ocean below. Other sharks utilise different forms of camouflage. For example, the angel shark rests on the seabed to hunt for mollusks and crustaceans, so to defend itself from predators that lurk above it, it uses camouflage that blends it in perfectly with the sand. Dogfish also use this method, but with a little less camouflage due to it not always being on the seabed. The tiger shark uses counter shading like the great white, but instead of a blue or grey upper body, it possesses a brown stripe pattern, from which it gets its name. Because the tiger shark tends to hunt in shallower waters, this adaptation is perfect for blending into the sand dunes from above. The basking shark colours itself brown all over, as many of the waters it prowls in are murky, and because it's a filter feeder, counter shading isn't necessary for hunting. I could go on and on about camouflage, but for the sake of the video, I'll just move on. When it comes to sharks, the nose knows. They have one of the most amazing senses of smell in the animal kingdom, if not the most efficiently used. In the snout are 2 nasal cavities, one for water to enter and one for water to exit. The shark pulls the water into these cavities, which then goes into large nasal sacs, giving the shark more time to register the smells. These sacs are filled with sensory cells, which go to the olfactory lobes in the shark's brain. These lobes detect whether the smell is of prey or a potential mate. When a shark is stalking its prey, the head shaking isn't for show. It's actually collecting more water to analyse, thus determine if its target is to the left or to the right. Surprisingly, 2/3 of the shark's brain consists of olfactory lobes, showing how necessary smell is to the shark to survive in the ocean. These lobes give the shark the ability to detect at least 1 part of blood in 1,000,000 parts of water, the equivalent of 1 teaspoon of blood in an Olympic swimming pool. These traces of blood can also be detected hundreds of meters away, giving its prey little opportunity to escape and hide. In conclusion, sharks have proven to be perfectly adapted for the environments they live in. From teeth to smell, these animals have astounding adaptations, which has meant they haven't had to evolve drastically in millions of years. However, these adaptations cannot save them from the threat of humanity. Every year, thousands of sharks are killed, some because they're caught in fishing nets and fishermen didn't care, others because they mistake the plastic we dump in the ocean for fish, choking and killing them, or being cold to make shark fin soup, an expensive dish that is often wasted due to its price. It's these atrocities committed by humans that are declining the numbers of these fascinating creatures. Companies like the Shark Trust aim to help increase their numbers again by putting fishing limits on sharks and protecting their breeding areas to ensure the next generation of sharks make it to adulthood. But they need our help. Without our donations and efforts, many species of shark may be extinct in the next few decades. Now is not the time to be sitting around expecting someone else to solve the world's problem. Now is the time for action.